Hang on, I think that was really quiet. Actually, I don't think you. It's possible you didn't even hear that at all. Let me try that again. One more time. Here, I'm gonna start again. Hold on.
Welcome.
To the joy of coding.
Hello, and welcome to episode 264 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. We're going to be working on Firefox stuff today. We're going to be thinking about Firefoxy things. It's going to be great. It's going to be a great time. Let's get started. Hold on a second. Hopefully you can hear me. I'm just checking the chat here. It's something I didn't even hear whatever you were talking about at all. Yeah, so I did a retake. I started and then I stopped and then I started again because the sounds weren't wired up correctly. But hopefully now you can hear the sounds. Like if I play this, hopefully you just heard that. Let me share my screen. 1 second. Here we are. Whoops, wrong screen, wrong screen. Wrong screen. Just give me a quick sec. Stand by, folks. Stand by. I guess I had disconnected some things from my screen or from my device. Wow, we're in shambles right now. Let me choose the right display here. I want the Asus. Not that one. There we go. This is the one I want. Yeah, that's what I wanted. OBS was very confused, but we should be good now. Let me just quickly check to see if the drawing tablet is... Yeah, okay. There we go. Okay, sorry about that. Welcome to episode 264 of The Joy of Coding. My name's Mike Conley, and yeah, let's get started. As you can see, no plan survives breakfast. Things could go horribly wrong. I might have to rejig OBS. I might have to, on the fly reconfigure things, and that's okay. You know, the thing about The Joy of Coding is that we kind of make it up as we go. There's kind of an outline of what I want to do, but things can go horribly wrong. We got snacks. I got some trail mix here. I'm sorry for eating and talking in front of you, but I'm hungry and I barely had lunch. I need to keep my blood sugar up. So, the first thing to note is that the agenda that we're looking at, that's right here in front of you, this is something that you have access to. If you're watching this on Air Mozilla, check out the video details over here on the left side. Oh, I got the direction right this time, on the left. If you're watching this on YouTube, check the video description. And for the folks on Twitch, whoopsie daisy, agendas here. Folks on Twitch, there is a guide here. This is the link, and I will just drop it in the Twitch chat in a sec. Sorry, I'm typing with one hand because I got my hand full of trail mix. All right, so there's the episode agenda. All right. The other thing I want to point out is that there is an episode guide. It's a completely viewer-driven, viewer-populated episode guide for almost every single episode of The Joy of Coding, and you should check it out. And there's a link to it in the agenda. And it's got, like, guides for almost every single episode I've ever done. And some of them go into pretty, like, deep detail of what we talked about, you know? Like, it'll have a summary of the things we talked about and some handy links and links to the agenda, all sorts of things. So... you should check it out if you want to know more about things I've done in the past, or if you're watching this in the past, what I've done in the future from this point. And if you want to send things, like maybe you have your own corrections, addenda, you want to expand on something I talked about, you can send me a pull request on GitHub for whichever episode you want to add notes for. I am very I don't have very high standards whenever it comes to this episode guide, so whatever is useful for you, I will happily merge it in. And if you're not sure what I'm talking about, or a pull request or a repository or anything like that, in the agenda there's a contributing excuse me, a contributing guide that kind of goes into detail on what I'm talking about there. Well, I think I got some peanut shell caught in the back of my throat. That'll teach me to have trail mix during a stream. I'll try not to eat more. So what are we doing today? What are we hacking on? Well, the first thing I actually want to do is plug a blog post by one of my colleagues, where if you are new or what do I mean? If systems programming is something that you haven't done a whole lot of, or maybe it's been a while and you have some interest in lower level things like how numbers are represented in memory, and how C does interesting things with numbers and why that can be super dangerous, you should read this blog post. It was by my colleague. It was published just today. I saw it go by this morning. And my colleague Molly Howell here goes on goes into like real deep on what caused a particular security bug and how it's related to implicit type conversion, like numeric type conversion in the C compiler, and how it was really non-obvious. But she goes into like really deep detail on how it works. And if you've ever wanted to learn about binary numbers or want a quick refresher on how they work, if you want a quick refresher on signed integers and 2's complement and how we do negative numbers with binary, and how implicit conversion works in C, this is a great blog post for you, and you should totally read it. It's highly readable, and I love the way it ends. First of all, I love the first takeaway is don't use C. Because these days there's not really much of an excuse to use C if unless that's the only compiler available to you. Rust, for example, is a much safer, better systems programming language at this point. It prevents you from blowing your foot off in the same way that this bug describes, how we were blowing our foot off with implicit type conversion. The last paragraph is, to me, the kicker, and that's what I really want to read out loud for you. Okay? You can do systems programming. Something I've hoped to get across. I is Molly Howell in this case, the blog post writer. Something I've hoped to get across, and I acknowledge this may not be the ideal topic to make this point, but it's an important point to me, is that low-level systems programming isn't magic or really special in any way. It's true, there's a lot going on, and there's lots of little details, but that's true for any kind of programming, or anything else involving computers at all, to be honest. Everything involved here was invented and built by people, and it can all be broken down and understood. And that's the message I want to sign off with. You can do systems programming. It's not too hard. It's not too complicated. It's not limited to just experts. You are smart and capable, and you can do the thing. And I fully support this. Like that, my perspective is exactly the same. I used to be just a front-end developer for Firefox. I'd use CSS and JavaScript to wire up logic, and I'd move pixels around in the CSS and the markup. But then I had the opportunity to learn some deeper level things about Firefox and how it works at what we call the native level, or inside of the platform in our sort of lower level systems, written, a lot of which is written in C++ and C. These days, a lot of it's written in Rust as well. And, at first I was intimidated, but, I was able to figure it out. And I think you can too. If you're a front-end developer, you can figure it out, what's going on under the hood. It's not wizards and magic under there. It's just a computer program, and you can figure it out too. And similarly, if you've been, doing back-end systems work for a long time, and you find front-end this sort of weird Wild West of technologies that don't make any sense, you can figure that out. There is it is not an impenetrable barrier between the two. I think the barrier between front end and back end is an artificial one. And I think my theory is that you become a more powerful, a more influential developer when you can do a bit of both. I'm not saying you need to be a full stack developer, but it's helpful to be able to have a higher level view of things and like a deeper understanding of how the systems interact with one another to do your job. And so if you're a front-end developer and or a developer who's never really thought about doing deeper level systems programming, you can do it. In fact, I have several people in mind, but one in particular who, interned at Mozilla, had no C++ experience to begin with, and walked out having written a number of really interesting, excellent patches in our native C++ layer, having learned both C++ and how Mozilla writes C++, because those are two different things. Like you have the C++ language itself, and then how we work with it on top of that, and all the abstractions we've built on top of it. And this person was able to do all of that in a matter of months, and so you can too. It just takes a little bit of practice and reading and experimentation. So enough me on my soapbox, but I just wanted to plug that blog post, and you should check it out. In fact, I will put a link to that in the Twitch chat as well for the people who want a quicker access to the link. So what I was thinking of doing today, in sort of the spirit of understanding like the system's low level like parts of Firefox, is I want to talk a little bit about one of the things that I started to research as part of my deep dive into understanding the platform of Firefox, or like the systems part of Firefox. Like I said, I was working for a long time on like CSS and JavaScript for the browser front end. I worked on the Thunderbird front end before that, and so I was very familiar with the JavaScript and CSS and Zool and HTML markup stuff. But then I was given the opportunity to work on a project called Electrolysis, which necessarily had me more involved in the deeper level parts of the browser, the platform. And if you're not sure what I mean by the platform, go check out episode 259, because I draw a distinction there between Firefox, like the UI, and the platform that I think would be handy. So if you're not sure what I mean by platform, or you want more information, pause this video, go watch 259, and then come back and play from here on. Okay. So this is also an opportunity for me to show off my drawing. I got this drawing tool, and I've moved my microphone and everything so I could draw things and explain things. And I think that's what I'm going to try to do today. So I'm going to be talking about dock shells, electrolysis, and browsing contexts, and fission, because these are all related to one another. And so we're going to start right from the very beginning. So let me switch screens to my drawing tablet, and you're going to have to bear with me. I'm still really new at Krita or Krita. I don't exactly know how you pronounce it, but I'm pretty new at it. So bear with me. Can I make this a little bit wider? No? Oh, yes, I can. Okay. All right, let's roll up the sleeves. Here we go. In the beginning, there was Firefox. And Firefox was a single program. I'm just going to call it firefox.exe and pretend we were just on Windows. But like, it was a single program. There were no content processes or anything. It was a single program. And then eventually we realized, it's handy to be able to sandbox things like the Flash plugin, like Homestar Runner. Here's Strong Bad. That's Strong Bad. We figured it was actually handy to be able to like run Flash. This is Flash. Inside of its own content process called the plugin container. And so Flash ended up running in here. Flash runtime. And for a long time, that's how... Oh, man, my writing's atrocious. But for a long time, that's how Firefox operated. Single program, except when you're running like a plugin like Flash. And there were other plugins that we might run inside of the plugin container, like the Java applet runner runtime thing. But that was the idea, is that single program. And now let's take a look at how that single program kind of organized documents, because that's key. Like I'm taking you through history, and so I'm gonna say that this is how Firefox organized documents from like inception until about 2014. Is it 2014? When did electrolysis ship? Hold on a second. Let me just look that up. Firefox electrolysis. When did that ship? Maybe it was 2017. On by default in 40 on beta. It went out in 2016. Sorry, let me erase this. This is important. We got to get our dates right. 2016. So this is generally how it worked. Remember what I said if you had watched episode 259, that the browser UI is also like a web page. You know, it's a document. It's browser.xhtml, which is a document that is loaded. And there's this thing that we have inside of Gecko, the platform, called DocShell, which is this, I think it's treated as this really mysterious thing. And it's kind of this class that has a lot of behaviors associated with it. And, you know, no matter what, the DocShell always seems to be involved. You know, people know, oh, maybe it's a DocShell bug. What is this DocShell? What DocShell? What is it? Well, the DocShell, this is my interpretation, my definition of a DocShell. A DocShell is the thing that's responsible for loading a document and, you know, doing all of the needful bits to kick off the network load to get the document data, figuring out how to represent that document, and then dealing with things that document might do, like navigate. You know, you might navigate away from that document to a different document. And so a DocShell is also good at like taking you between documents. A DocShell can navigate. So we have this thing called the DocShell. And let's say it loads something called, the top one loads, at the time it loaded something called browser.zool. That was the top level like document type for the browser UI. It's called browser.zool. And so this was a DocShell there are two different types of DocShell, a Chrome and a content DocShell. And again, that's a piece of information that if you're curious about that distinction, Chrome and content, go watch episode 259. But this was a Chrome DocShell because we were loading a Chrome URI browser.zool, and then you'd have inside of that browser.zool individual tabs like what we have right now. In like, if we go back to my screen, whoops, if you go here, you know, you've got the browser UI, and then you have this content area, and that is a thing that can load documents. So you've got these like child DocShells. So you'd have for each tab. So I'm gonna say, let me go back to the drawing. Sorry, if I ever switch away back and forth between drawing and not drawing, and I haven't like I haven't transitioned properly, let me know. So for each tab, so I'm gonna, oh man, I have to get the pressures right here. Each tab, so you might have several tabs. Let's, for example, say we have 3. Each tab would have an associated DocShell. I'm just going to use DS. And that would load like the individual pages. So these would be content DocShells. And content DocShells have different rules, different things that they're allowed to do. You know, a Chrome DocShell has more powers, more privilege than a content DocShell. For reasons like, there are certain things we definitely don't want web content to be able to do. And maybe you remember there are these things called frames or iframes. These are documents within documents that can be loaded and navigated independently. And so that means DocShells can have other dock shells. And these are necessarily content dock shells. And like, it can go on forever. You can have an arbitrary number of iframes, which can contain iframes. Maybe this one over here doesn't have any. Maybe it doesn't have any iframes, but this one has one. And this one here on the left, over here, let's say this one has like a bunch of iframes that just keep nesting and nesting and nesting. Now, what this structure is, hopefully you recognize this structure. This is back to data, like computer science data structures 101. This is a tree. What we have is a tree of dock shells. And these dock shells can navigate within themselves. They navigate independently. However, whenever, like, say this dock shell right here, this one with on the left, if it navigates, then the dock shell associated with the iframe that it has in its document would get destroyed, and all of these all of these children, this entire thing would get severed right here. It would just go away. All of this stuff would go away, and then a new document would load, and it might have iframes or something, and it would like create a dock shell for each iframe. But that's generally how it works, and that was how it worked for many years. Now let's move into the future. Again. So now it's 2016. Well, let's take it even earlier than that. Multi-process browsing suddenly becomes important. I think it was actually Internet Explorer that pioneered this technology. I could be wrong about that, but Chrome, the Chromium browser, made it famous, where instead of having a single monolithic browser, loading all of your stuff, you broke it down into different programs. So this would be like browser process, and then Chromium have these things called renderer processes. And these are different programs, renderer.exe. It's not actually called that, but that's how I'm differentiating processes, because I don't have good symbols for that right now. And then within these, they have their own notion of things that can like load documents. I don't think they call them dock shells, but they call them something else. But like those little trees would exist within there, within these little processes. And we ended up doing something very similar in Firefox. As part of the electrolysis project, we ended up having this model. So electrolysis. Whoops. Oh man, did I just switch tools? Yes, I did. Let me go back to the tool I was at. Electrolysis happened. How do I avoid hitting that button? Okay, electrolysis happened. And so what we ended up doing is very similar. Where, I mean, again, you've got your main firefox.exe up here. EXE. And we reused the plugin container technology that we were using for Flash and other plugins, and we basically recycled it so that we could load arbitrary web content. And so this was still a dock shell. We had like a top-level dock shell in here. But then it wouldn't have any children for the browser UI. Like you'd have browser.zool loaded in a dock shell. I can spell. Browser.zool loaded in a dock shell. But there would be no children to it. Because the children, like for those individual tabs, let's say we've got 2 tabs now. Those individual tabs would have a separate program called, well, we called it plugin container still. We never renamed it. Plugin container. And these are plugin container. .exe. Again, I apologize for my horrible handwriting. I don't write often. I don't handwrite often. And in here we'd have our dock shells. Our dock shell tree. Dock shells. No, we might just have one here. And the relationship between the tab and the plugin containers, This would happen over what we call the IPC, or inter-process communication layer, where we'd send messages back and forth between the processes. And, switching tabs, you'd have to send a message, for example, from the parent to the individual plugin container and tell the plugin container, like, hey, we're showing you now. We're painting you. So paint, upload your layers, paint and upload your layers to the compositor, that sort of thing. Or a mouse is moving over you at these coordinates. What do you want to do about it? So a lot of communication ends up happening between the parent process and these plugin container processes, or the content processes rather. And you'd have these individual doc shells within them. And so effectively the along with the IPC boundary and the communication back and forth, like the big critical change between the previous model and this model was that we had severed the connection between this parent doc shell and the parent process up here. We'd severed the connection between this doc shell and these doc shells down here. But within these programs, the plugin containers, the trees were basically the same. We had trees of doc shells, regardless of whether or not you had an iframe that belonged to the same domain or not. And that's going to become important for the next part, which is fission. So, fast forward. Electrolysis shipped to great fanfare. And, it improved the security and stability of the browser, because whenever we load content, let me go back to this. When we load arbitrary web content in one of these plugin container.exe processes, we can do a lot more with the operating system to lock down those processes to prevent them from doing dangerous things. Like before, back in the day, because everything was running within this, like, the same global Firefox.exe. Wow, my handwriting. I need to, anchor myself. But they were all running in the same parent process. It meant that if any of these, if you went to evil.com inside this content, this doc shell here, and it figured out a way of exploiting memory, then it was basically running with full parent process privileges at that point. Like your password database is in this process, and all of your history, and bookmarks, and the ability to talk to the operating system is in this process. And so a bad actor that could take over Firefox.exe had basically full control of your machine. It was like Firefox.exe could go evil in that particular case back in the day. And then electrolysis made that a lot harder, because if it takes over the plugin container, well, we can sandbox the plugin container and prevent it from doing certain things. So even if it was taken over, it's a bit like, just security sandboxing is what we called it. And yes, it's still possible to cause what's called a confused deputy problem, where a compromised plugin container.exe could, in theory, send messages up to the parent and confuse the parent into doing something. But it's a lot harder, and we can add protective barriers and assertions with those communications layers. And if we can detect that one of these plugin containers has gone rogue, if it seems to be behaving strangely, we can just have the parent kill the process, and then it's just gone, out of memory, and that's much better. And the other thing is, if a plugin crashes, if the plugin container crashes, the web content just does something, or the plugin container.exe is just it can't handle something and it crashes, it then doesn't end up taking down the entire browser. It just takes down any tabs that were loaded in that content process. So we shipped electrolysis again back in 2016 for the first time, and it improved the stability and the performance and the security of the browser. By the way, if you have any questions about anything I'm talking about, please just drop them into the chat, and I will do my best to answer them. Okay. Especially if you have questions about doc shells, because that's what I've got on the brain right now. Okay, fast forward to now. we've been working on something new called fission. And fission is different from electrolysis, but it builds on top of the same infrastructure. Whereas before, like if you go back to electrolysis, we would load the like subframes of a tab within the same content process. So if you went to evil.com, and the top level, doc shell there, and then it created an iframe at bank.com, and bank.com loaded. Wow, handwriting, come on. Bank.com. They would be loaded in the same content process. And if evil.com could figure out a way of compromising the content process and reading memory arbitrarily within it, then it could, in theory, read information from bank.com. Like, for example, your authentication token in memory or something. Or, really anything in the content process. So that's bad news. That's bad. And in I don't remember what year it was, but the Spectre and Meltdown security vulnerabilities that were reported a number of years ago, these security researchers realized that the way that CPUs were designed, it was actually simpler than anyone realized to slowly read memory from within the same process without needing to like compromise the process. Like you could kind of ping around using special techniques and timing. Basically, it was a timing attack to figure out whether or not certain values are in memory, or certain things are in memory. And through that, you can sort of deduce information about what's in memory for a particular process. And that's bad, because it meant that evil.com had instead of having to find like a really sophisticated browser exploit, they could just use this technique to scan the browser memory, the content process memory, and get information about the other iframes that were loaded in it. And that's bad. And so we deployed a whole bunch of, as soon as we figured that out, like the security researchers like let everyone know, browser developers everywhere, because browsers are particularly vulnerable to this sort of thing, and users of browsers are particularly vulnerable to these sorts of attacks, because what you're doing when you browse a website is just downloading and executing arbitrary code that you've gotten down through the network, and like it could be anything. And so browsers were a perfect sort of delivery vehicle for this kind of exploit. And so browser developers, all of us, just at the same time, deployed countermeasures to make it a lot harder to use those techniques to scan memory. And if you want to know more information about this particular class of attack, I want to share a blog post with you that I think you will find interesting, written by my colleague Annie. I always choose the wrong one, so let me just put this in here. Site isolation architecture in Firefox. And this kind of goes into some detail about Meltdown, Spectre vulnerabilities. And in particular, Annie talks about how it's in theory possible for attacker.com. It doesn't even need to necessarily load the iframe. It just needs to be in the same content process as bank.com, and then it could like read memory. So give this a read, because I think you'll find it very interesting. And it also leads into what I'm about to talk about next, which is fission. So fission is sort of, like I said, we deployed all those countermeasures to make it harder to exploit that memory reading capability. But the sort of the long-term solution for Spectre and Meltdown, at least, is what's called site isolation. And site isolation means within a content process, only load a particular domain or a particular site. So if you have a content process that has a facebook.com page loaded in it, you know that every other page in there is also from facebook.com. And that means effectively that if you load evil.com, a content process should be created for it, and evil.com should only be able to access, if it decides to go evil, any other evil.com pages, like any other the memory of other evil.com pages. It should just be within itself, because basically what we're taking advantage of is the process separation model of modern operating systems, which is not susceptible to the same meltdown inspector vulnerability as like same process boundaries, memory boundaries. Smurf D asks, when this happened, did Firefox and Chrome work together to figure out countermeasures, or were they doing their own thing? You know, it was pretty, whenever security things like this come up, we are very tight-lipped about it. We only involve the necessary people, and I was not involved. I was not there whenever the news dropped. Like our high level, at the highest levels, it was like communications, I think, occurred. The vulnerability was disclosed, and like our researchers went on it and really sort of spec'd everything out and figured it out. But I was not involved, so I don't actually know what kind of conversations were happening between browser vendors, between organizations. Like, this is not just browser vendors, but there are a lot of people who are interested in, who have a vested interest in this stuff, who contribute to browsers, who care about the web as a whole, and like Intel and AMD, or I think it was just, I don't know exactly which processors were vulnerable to this. I know Intel was, but basically anything that did like branch prediction, which was a pretty common optimization built into the silicon of CPUs, modern CPUs, and is the sort of the heart of the Meltdown Inspector attacks. They cared a lot too, and maybe there were conversations between all these different stakeholders, but I don't know. I wasn't there. Stephen Weir asks, if you only load one domain, how do you link external JS, CSS fonts, etc.? Great question. So I should be more precise, and when I say we only load things from one domain, I mean pages. So you can load JavaScript from a different domain, but you can't have another page. There's a distinction between loading. Hang on, let me draw for a second here. There's a distinction between evil.com and let's say you've got like the Google CDN with jQuery, the jQuery library or something. There's a difference between loading like the jQuery JS from Google's CDN versus having evil.com have like the Gmail application also running inside of it, or like, because when you load something from another location, there are different rules applied to the sorts of information in the transactions that occurs. Like when you go and get fonts or images or CSS from another domain, we don't necessarily send any information that the content process didn't already have. Like, I don't believe we don't end up returning anything like authentication cookies or anything, or we shouldn't. I'm a little outside of my domain of expertise there, but I know that the types of navigation, the types of network requests are different, where loading assets, static assets from another domain is allowed, but actually loading pages and executing pages with the like execution being for like Gmail. Man, how do I verbalize this? Loading Gmail is different from downloading the assets and executing the assets from Gmail's servers. Is that true? Yeah, because one is known to be Gmail, and these are just assets from Gmail that I'm reusing for my site. Hopefully that makes sense. But we treat them slightly different. Let me erase this stuff. Okay, so with Fission, what we end up doing, or what we end up with, is we've got our like Firefox.exe. And for this, I'm going to need two domains. I'm going to call them a.com and b.com and maybe c.com, just so that we have like a language for referring to different domains. So Firefox.exe, and you've got your tabs, and we still have a doc shell. But what we have, say, for an individual tab that's at a.com, let's say we've got a process called a.com.exe. It's not actually named after the domain, but we label the content process so that we know that it's for a particular domain. And let's say it has a doc shell that loads an iframe. It loads an iframe for b.com. Well, what you end up with actually is another process called b.com.exe. And this stuff is rendered in here, and there's a doc shell. And there's a thing in the parent process that knows about b.com.exe, but it's not a tab. It's a completely different abstraction. But we're recreating a tree again, but you don't necessarily have contiguous contiguous edges between doc shells. Process boundaries might occur between the doc shells within a tree of doc shells. So for example, if we want to really sort of go convoluted, this iframe for b.com could have an iframe that's also at a.com. And that iframe is actually loaded over here. And it has a doc shell, but it's remoted so that it's running within the a.com process. So the idea is, I'm not doing a very good job of drawing this, and Annie's blog post does a way better job of illustrating it, and you should check it out. But basically, what we end up doing is grouping frames that belong to the same domain into content processes together. So Facebook.com is within a content process, Google.com is within a content process. And we're still tinkering with some of the rules on how we do the grouping, because even though we want all of Google.com inside of a content process, we also know that there are a lot of Google.com applications that are really heavy. Like Gmail is very heavy, Google Docs is very heavy, and those have different domains. So that's not a very good example. But like Google Meet, meet.google.com, and docs.google.com ultimately have the same domain, like what we call the ETLD+1. And those are both very heavy applications. And so we might tinker with things so that, eventually we realize, oh, well, this google.com process is getting quite large. Let's create another google.com process alongside of it to load things in. And that way, meet.com doesn't end up bogging down all of your docs.com pages, etc. Because we don't have that. Pre-Fission, that kind of problem was less likely because the way we do content process assignment is random. Well, not super random, but it's a round robin where we just go to the next content process to load a site and then the next content process, etc. Okay. So how do you manage all of these doc shells that are all over the place? How do you do it? Because before it was a lot simpler. I mean, it wasn't easy, but we made it work where you just had this one sort of separation that happened here. And a lot of the job for electrolysis was managing this boundary and just sort of fulfilling the expectations of the doc shells and all the stuff in these content processes and the parent process so that things could occur asynchronously across the process boundary. But whenever you've got all of these things in a bunch of different processes, and they're kind of wiring back and forth, you end up with a big mess, a big ball of mess. And so how do you deal with this? It would be really nice, like back in the day when you had these dock shells all in a tree, it was actually a lot better and easier to reason about. And it's almost like where things are running and in which content process things are running. These are almost like implementation details. It'd be really nice if we had this tree structure again. And so that's what browsing contexts kind of are. Now, I should caveat all of this by saying I did not work on browsing contexts. I did not design them, and I'm not on the DOM team. The DOM team, in particular the people on the DOM team working on Fission, are much better positioned and equipped to do deep level definitions of what a browsing context is. What I'm trying to do is explain what I perceive as the definition of a browsing context as a front-end developer and as someone who's periodically bumped up against them. This is how I've seen how they work and what they do. So, a browsing context is a thing that represents... Oh, SmurfD asks, I was going to say, what happens if you open a tab to b.com that you already have opened in a dock shell? Like if you open up a tab over here and it goes to b.com, well, it might choose to load b.com inside of the b.com process, but it would create a new dock shell and a new load for the b.com document in that dock shell. That's what would happen. Unless we decided to split it out. If this process was suddenly really heavy, we might split it out into yet another b.com.exe and load the dock shell there. We might. It really depends. I think it really depends on memory pressure. So how do we manage all this stuff? Browsing context. Let's get into it. I hope this is interesting. I don't know if this is interesting, but I hope it is. Let me know in the comments if this is at all illuminating or if I'm just wasting your time. Hold on. SmurfD says it's interesting, so that's all I needed to hear. Thanks, SmurfD. I can always count on you. Maybe instead of trying to define a browsing context, I should draw out my mental model of it first, and then maybe we can apply a definition to it. Because I'm not even sure I've ever put a definition of browsing context into words. In fact, I am well aware that we have some documentation. We have some documentation for what we call JS actors, which are the things that we use to communicate between processes these days. And there's this section on browsing contexts where it's like, these things are all to do. Like, what are these things? To do. No one's really done the work of defining them yet. So I'm sure the DOM team could do a much better job of defining them than I could, but I'm going to do my best. All right. Again, let's say we're loading a page that has multiple iframes and each one loads to different domains. It would be great if we could represent that as a tree. And that's what we do. We create, you can almost think of as a browsing context as like dock shells, but if we could do them again with the understanding that things are going to load in different processes. Thank you. I just got a coffee delivery. Thank you for that. And so every, let's go back to our first drawing here for a sec. We've got this sort of very complicated relationship here between different tabs and processes. But ultimately what we have here are three tabs, and each tab hang on, let's go back here. We had three tabs. We actually never said what this tab did. So I'm actually going to get rid of that tab. Let's say we only have two tabs. That simplifies things. We got two tabs. And the first one was at A.com, and it had a single iframe loaded at B.com. That's one thing we know. And then we know that second tab had a second tab was also loaded at B.com. Oh, and there was also another iframe. So that B.com subframe had a subframe to A.com. So sorry, there was another one there. So it's like you had A, B, and then A again. That's what we said. Very convoluted, but that's what we set up. And then we also had the second tab pointed at B.com. Okay. So that's the conceptual model of how things have been like structured. With if we just think about them as domains, and we use browsing context to replicate this model. And what's particularly useful is that everyone has a copy of this tree. The one that's right here in front of us, everyone gets a copy of it. Everyone involved gets a copy of it. So A has a little copy of this browsing context tree. So I'm going to just draw this little shape. It's like it knows about, and this one knows about it. Actually, you know what? Hold on. I'm slightly wrong. There's a slightly more restrictive knowledge. So A knows about the browsing context that tree that it's involved in. So it knows about this. This one knows about this. And this one also knows about this. And these three little balls represents this sort of subtree that's happening here. The parent knows about all of them. And B knows about itself. I'm reasonably certain that's how it works. Okay. So every process or every one of these things has a notion of its own. Every page has a notion of its own like browsing context tree. That's the first thing to note. The second thing is that the parent has a very special view of the browsing context tree called the canonical browsing contexts. Which is like a browsing context, but more. It has slightly more information on it. But what's really nice about this structure is that as the documents navigate, so for example, let's say B goes to C.com, so I'm going to erase, let's just simulate for a second here that B goes, this frame right here that you can see, let's say it goes to C.com and it unloads its iframe. Then we're going to get rid of that. Make it. We get rid of that. Then what happens is this goes here. Then the browsing contexts all get updated automatically. The sort of the browsing context infrastructure does that for us. So that's one thing. The second thing is that these little browsing contexts are kind of our gateway for communicating back and forth. So if you are like some privileged JavaScript running inside of the parent process, so like this is the parent up here, and these are content processes down here, then privileged.js can like choose a canonical browsing context and send a message to a particular one of them to tell it to do something. And we do that using JS actors, which is that documentation I was just pointing at. You can choose a browsing context in the parent process and send a message to it and say, hey, do this, do that. And they can send messages back up to the parent. And I believe with some restriction, browsing content can send messages to one another. But there is I actually could be wrong about that. It might all need to be marshaled through the parent, because you have to remember what we're trying to do here. We're trying to avoid content processes from knowing too much about each other. That's the whole point of this thing. Site isolation is to try and keep them operating in their own little worlds, and so that they can't talk to one another. Because if they could talk to one another, they could then learn about one another, and then you're back at square one again. Because if evil.com's process can like learn about other processes around it, and then it becomes compromised, or it can use like Meltdown or Spectre, then you're back at the same problem you started with. So we're trying to put in a lot of infrastructure to avoid these browsing contexts, these content processes, and these browsing contexts within the content processes from learning too much, from communicating with one another. They have to be marshaled through the parent, so that the parent can say whether or not, like, okay, is this content process supposed to be able to talk to this other one? And usually the answer is no, unless they belong to the same domain, in which case I think we do allow it. And so the parent does a lot of like gatekeeping and access management control. And, that's all taken care of in a lot of our sophisticated DOM code, which I don't really understand or deal with much. And each browsing context might have an associated doc shell. So in this case, it maps to like the node that lives, the browsing context that lives in the content process where the associated frame is loaded, has a doc shell associated with that browsing context. But the other one does not. It's just nothing. That'll be null. I'm using the ground symbol there. I don't know why. And then over here, there's a doc shell. And the parent has no doc shells. Like none of them point at any doc shells, unless they happen to be loaded in the parent process. And there are very few pages that do that still. The only ones that I can think of are like internal pages, like about config or about preferences or about add-ons. No pages loaded over the internet load in the parent process anymore. Let's see. What else do we want to know about browsing contexts? Well, I want to sort of illustrate something else I've kind of got in my head as part of the browsing context model. You may have heard the term inner and outer window, and this has to do with how navigation works. So we have in the DOM with like browser navigation, you have this notion of like a window. And I don't mean like a window in the sense of an operating system or a browser window. It's just like if you go into your JavaScript console and you type in window, that is a thing. There is a thing called window. What is that thing? And if you have an iframe, you have access to an iframe, there's usually a property on it called window. What is that thing? What is window? Okay. So let me see here. This is what I'm going to draw. What we have here is what's called the sliding window metaphor. So suppose you've been to 3 pages, A, B, and C at different domains. A.com. Let's forget about processes all of a sudden. Let's just pretend we're back in Firefox one days, and we don't worry about process flipping, but you were at A.com, then B.com, then C.com. We don't have to worry about any sort of sophisticated browsing context. This is not what we're talking about. We're talking about just the sliding window metaphor. Whatever page you're on, the inner window is the one that's associated with the site. So there's an inner window for each of these. But suppose that this box on the outside here is actually a site called Mike.com, and that this is an iframe. Mike.com is running some JavaScript to navigate this iframe to go from a.com to b.com.c.com, and it has access to the iframes window property because I'm pretty sure, let me just, this is kind of like iframe 101, but I'm pretty sure if you have an iframe, here's an example of an iframe. I'm pretty sure if you inspect the iframe, if I have an iframe here, I think you get something called, no, not window, content window? Content window, that's what it's called, content window. Content window, whoops. Let me go back to drawing. Content window. Content window. And that thing does not change as you go, as like you navigate between a.com, b.com, c.com. Like, I'm going to go back to, let's do an experiment. So this is a page where like the subframe will navigate. Like if I click on this, the subframe will navigate. Great. So we have that sort of sliding window model, but there's only, you know, one page and then the other page. What I'm going to do is I'm going to get access to the iframe here, access the content window, and I'm going to put an expando property. I'm just going to call it like underscore underscore mconley equals true. And then I'm going to navigate the page. And I hope I'm right about this because I could be wrong. Maybe I've got all this wrong. But if I do that, oh, it is undefined. Shoot, maybe expandos aren't persisted. Hold up. Outer window, content window. Let x equal content window. And now navigate it. Let y equal content window. Are they the same thing? True, they are the same thing. Okay, so the expando got cleared, but they are the same thing. The content window, the outer window did not change from one navigation to the next. However, the inner window definitely changed. Like the inner window for each document lives and travels with that document. So there's an inner window for I'm a subframe here, and there's an inner window, a separate inner window for subframe navigated. And there's a kind of a barrier between the two. A little bit of a barrier, but there's some glue. But basically, you can almost think of it as like a spaceship undocking and another spaceship docks in. Like, that's the relationship between the outer window and the inner window. And there's like a little bit of communication between the two. And then a navigation occurs, and we unplug the one inner window and we plug in the other one, and communication can occur. And if you want more detail on that, outer window, I think there was a inner and outer window. I think there's some documentation, inner and outer windows. Don't tell me it's been, okay, it's been archived, but let me see if I can find it. Archive, MDN archived content, ENUS. What was it called? Inner and outer windows. It's probably outer windows right here. Developer guide. Oh, that's an RU. No, I want an ENUS. Here we go. So this is a very poor state of things. We should probably try and revive this. In fact, I should file a bug to do that. But let me just drop this into a jsbin.com. Here we go. This kind of goes into what an inner window and an outer window is. And in fact, it uses terminology like browsing context. Browsing context is a term that's actually baked into the W3C like definition of what how a user agent is supposed to work. Like there's a specific definition to this thing. In fact, it's the WattWG, not the W3C. A browsing context is an environment in which document objects are presented to the user. I guess that is the definition there. And the browsing contexts within Firefox are very similar. That's kind of their definition. But they don't care about process boundaries. That's the other thing. A browsing context can be pointing to a document that's being loaded in a different process. And that is the distinction with how we define browsing contexts in Firefox. Okay. So, back to drawing. We have the inner windows, we have the outer windows. And why did I want to bring that up? It's because what I think of as like a dock shell, a browsing context, and an inner outer window is this kind of like ball of things that ultimately constitute like a document having loaded. So let me create yet another drawing. There are lots of different things that get created whenever you are loading a document, but just say we're in a content process. One of the things that you have is you have the browsing context, and then you also have, it's not an arrow, you just have a line to a dock shell, which also has an outer window, which has an inner window. And you might ask, like, why bother keeping the inner window if we're just going to, like, if the next page navigation is going to throw away this entire content process? Well, it might not. Like, if you do a same domain navigation, we would end up just swapping out the inner window for, like, if you go from a.com/1 to a.com/2, we stay in the same process, and we just throw away a.com/1's inner window for a.com/2's inner window. So that's how that works. Whoopsie daisy, what just happened to Krita? Oh, I just moved it. Hold on. I just moved it to the wrong. Thank you. That was very disturbing. I apologize. Okay. See, which tool am I supposed to be on? That one? Yes, okay. And I like this drawing tool. And let me undo a couple of these lines that I drew. Okay. And then you have a thing called a pres shell. Come on, why can't I draw? There we go. You have a thing called a pres shell. And this whole blob of stuff, this is like what ultimately talks to like graphics and layout. Or it's actually in the opposite order. This is the thing that ultimately talks to like the style, layout, and graphics. Like pres shell is basically the thing that dock shell talks to in order to initiate presentation. It's the pres in pres shell is presentation, and so it knows how to like kick off all of those things. And this big ball, and like the dock shell knows how to like talk to the network, Netgo. And there's a thing as well called like the content viewer. And like I think these two know how to talk to one another because the type of content will like the way it's presented will depend on the kind of content it is. Because for example, an SVG, this might be interesting to you. I believe I could be wrong about this, but I'm pretty sure an SVG is a kind of document. It absolutely is. An SVG is an XML document that just ends up producing a vector image. And so it has a dock shell, I believe, and it has a particular content viewer, an SVG content viewer, distinct from the HTML content viewer. And, you know, so it ultimately results in sort of a slightly different set of rules on how it presents in pres shell. But I'm pretty sure it ends up creating a dock shell for an SVG. Don't quote me on that, but I'm pretty sure that's true. an outer window, an inner window, a browsing context. So I think that's all I wanted to say about all of this stuff. Like I haven't done a really thorough job of defining it, but I've kind of like I've drawn this cloud of concepts that are all related to one another, and that's kind of how I think about it in my head. You know, these things. It's a motor for displaying a web page, and it's got all these one-to-one relationships because each of these classes, each of these things does something very different. They have different responsibilities, and they have to survive same domain document navigation. And so, like, whenever you do a same domain document navigation, the pres shell gets thrown out, the content viewer gets thrown out, the inner window gets thrown out, but we keep the rest of it, and then new pres shells, new content viewers, new inner window gets created. I'm sort of eliding there. There's some complexity with what we call the BF cache. So for some pages, we don't actually end up throwing away the pres shell and content viewer and inner window. We put them in what's called the BF cache. And that's what makes it quick to go back to a page you were just on, is we just pull those things out of the cache and bring them back to life. But if we can't put them in the BF cache, then we throw them away, and then these things survive. And that's why they're kind of separated out in that way, so that we can quickly like detonate, blow the connections, and create new ones while keeping the dock shell and the outer window alive. And the browsing context is our way of communicating. Or I remember what I wanted to talk about. There is a thing called the current window global, which is a new thing that's kind of dangling off of the side of the browsing context, which is a kind of cross-process representation of the outer window. But what's neat about it is that back here in the parent process... hang on. Oh, come on. Back over where? Here? Back over here in this sort of representation of browsing contexts, you don't have the dock shells in the parent process, but you do have these like current window globals, CWG, that are maintained. So you don't have access to the dock shells, but you do have access to the current window globals. So actually, let's do a little bit of exploration. This might be interesting to you, but we can actually do some manipulation of dock shell, or not dock shells, but of browsing context. I'm gonna let's throw together a quick build of the latest Firefox, and then we can open up our dev tools and kind of explore around. 4msal4 says hello, and I'm gonna say hello back. While we're waiting for this build to complete, it shouldn't take more than a minute or so. Let's see what kind of questions we have here. Question 1. I'm really confused how the build system works, how they create binaries, and how do the C++ files get built. The Firefox source code seems to be a bit esoteric. It would be helpful how jar.mn, moz.build integrates together. Okay. Moz.build, these are effectively Python instructions on that build dependency graphs that ultimately get fed into something like a makefile, and then we do a thing like make. So that's what moz.build files are for. They're building the dependency graph between both that's how we communicate, like, okay, these are C++ files. These ones are meant to be unified into a single C++ file. These ones maybe shouldn't go into the same DLL as these others. Maybe these ones belong to their own DLL file. That's all defined in moz.build. It also, moz.build helps define what gets packaged in omni.ja. So what gets packaged in omni.ja. And then we have jar.mn, which goes into more detail on what gets packaged in omni.ja. Like, I think in particular, moz.build defines things like resources. So JSMs, JavaScript modules. And then jar.mn is how we go into more detail on like HTML, Zool, CSS, and some JS, and how it gets packaged in omni.ja. And omni.ja, that's our asset folder. It's basically a zip file. We removed the R because some things weren't liking the fact that it was called a jar. But if you right click, if you here's an exercise. Go find your Firefox install folder. Find omni.ja. Copy it somewhere else on the file system. This is important. Don't do the next step inside of the Firefox install folder. Rename omni.ja to omni.zip. Unzip the file. And what you'll get is the assets of Firefox, like all the JS, the CSS, the images, everything. And jar.mn is used to define what goes into omni.ja, as well as what to override from previous jar.mns, because there are shared jar.mn files in like the shared toolkit folder, and then the Firefox jar.mn file says, okay, well wait, instead of packaging those things in our omni.ja for Firefox, we want to replace some of them, or we want to remove some things from toolkit that we don't necessarily need. Like there are a bunch of directives inside of jar.mn that you can use. And so I think what happens is that during the build phase, I think I'm going to guess that moz.build runs first and builds up the dependency tree to figure out how to package these things. And then at some point, something processes jar.mn to do refinements on how things are packaged inside of omni.ja. I'm seeing some complaints about stream lag. I apologize. I am recording this. I will be posting it to YouTube after I'm done. So hopefully, I'm sorry about the lag. I don't appear to be dropping frames though. So our build is done here. And I would just want to do a couple of quick demonstrations on what we can do now that we know about browsing contexts. I'm going to open up the browser toolbox. And let's go to a page. Let's go to my blog because I'm vain. Let's go to mikeconley.ca. Okay, so what's interesting about this is that we have my blog at the top level, and then we have an iframe that loads the YouTube video. That's how YouTube video embedding works, is it's an iframe. And so if we go to the console here, we can actually get access to the selected browser here. That's the browser element in the parent process. And we can get access to the top level browsing context. That's the canonical browsing context, because remember, we're executing this instruction in the parent process. And we can know about all of the like children of the browsing context. And we know that there are 2 children. I don't actually know what the second one would be. Let's look at what the first child is and figure out from its current window global what the current URI. Can we do that? Current URI? Current window global. What else can we figure out about it? Can we figure out what the URI is? Outer window ID. How do we figure out document URI? Current window global document URI dot spec. So the first iframe, the first child, it's an iframe pointed at YouTube, and I'm actually very curious about what the second one is. Oh, I've got 2 YouTube videos on here apparently. Both pointed at the same. Did I do it twice? I did it twice. I've got 2 iframes pointed at the same document. I got the video on here twice. That's why. So I've got 2 iframes, and I'm doing all of that checking from within the parent process because we have this browsing context abstraction. So again, the browsing context belongs to the top level document here for the browser, and then I get let's say I can get the first child browsing context, and then I can get its current window global and figure out what the document's pointed at, all from within the parent process. I don't have to reach in and send messages. The DOM layer is taking care of keeping this all in sync for me, so that if I, for example, end up navigating this iframe, which in theory I could, I don't actually know how I'd navigate this iframe, but then this would all get updated for me. And so what can we do with this browsing context? Well, we can see, for example, that it belongs to the, it's a web content process, and we can map it to the browser that it's loaded in, which is handy. It's got a special ID on it. We can find the window associated with it. We can actually notice that it'll survive navigations. Like if I say let BC equal browsing context, and then I navigate, then BC should be the same. So it's very similar in some ways to the outer window in that it survives navigations. However, the inner window, let's go back again. So BC is still true, but if I do gbrowser.selected browser browsing context current window global, and I say like let CWG equal that, and then I navigate again, and then let's see if CWG equals that. No, it doesn't. So the current window global swaps out as you navigate. And, you know, that's handy because it's possible for the current window global to have ended up being in a different content process, for example. Like, if I were to navigate to a different site, like, let's go to the CBC, I'm pretty sure that the browsing context doesn't get thrown away. Yeah, we keep the same browsing context, but the content process, if we look back up at the old current window global from my blog that I was on, we can see that it was loaded in content process OSPID 25617, whereas this one is loaded in 25617. That doesn't make any sense. Current window global. Oh, header window ID 25. Did I unfold that too late? Let's do this again. Let's go back to my blog. 25617. Do I have Fission enabled? I wonder if I don't have Fission enabled. Fission auto start is off. Fission is off. That's why. Let me restart. So let's try that experiment again, now that Fission is on. Current window global, OSPID 26684. And let's set the browsing context to be equal to, like, we'll set this variable BC to be the browsing context. If I navigate again, the BC should not have changed. But then let me go to cbc.ca. Browsing context has not changed. But the current window global 26684 was the old process ID on my blog, and on this one it's 26685. So we did an entire process flip. So a current window global gets swapped out, and it might belong to a completely different content process. And that's kind of the nice thing about browsing context in current window global. It's these primitives that exist inside of the parent process that kind of map to the, oh, what is going on with these buttons? There's something super broken about the UI in this nightly. I don't know what happened here. I'll investigate that later. But that's the nice thing about browsing context in current window global, is even though we have this separation between content processes, browsing context and current window global help us organize things in a nice way that doesn't mean that it means that we have to care less about what process a thing is in from things like the front end. We just kind of use browsing context in current window global and use messages, and the DOM layer takes care of it for us and greatly simplifies things. So that's my talk about browsing context and doc shells. I hope that was interesting. Let me know in the comments, in the rate this episode form. Let me know if you'd like more of these deep dives into these things. If you've got additional questions about dock shells or browsing contexts, I'm happy to try and get them answered for you. And speaking of questions, I'm going to try and answer some of these other questions before we close out. So, can you talk a little bit about the history of the intro and outro jingle? Sure. So, if you want to hear it again, here it is.
The joy of coding.
Okay, so this is this jingle was written by my friend Barn, who is also the lead singer of my band. So you can find Barn, you can find my band at Bandcamp. Bandcamp. This is the band's called The Johnson Report. Bandcamp. We have music videos that you might care to watch if you'd like. YouTube, The Johnson Report here. Music videos. You can watch me being a fool. Watch me being a ham. And Barn himself has a YouTube channel, Hermit the Fraud. And he does a lot of covers. Barn's channel. He does a lot of covers. They're really good. He's a very good musician. And he wrote the jingle that I'm using. And what I did was I had asked Barn for something like the beginning, like this, the hook from the song "She Says What She Means" by the band Sloan. And if you're curious what that sounds like, I'm not going to play it because I'm probably going to get a DC made takedown or something, but I will link to it here. And once you get past the intro, the boom, 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 once you get past that, there's this hook in the song that goes like, ba-na-na-ba, and that's what I was modeling the joy of coding off of. And that's basically like the jingle. And that's what I communicated to Barn. I said, can you throw me together a jingle that sounds just like the hook from She Says What She Means by Sloan? And he and I both like Sloan. He knew exactly what I meant, and he just ran with it, and he did a great job. When you mentor someone, what does the process look like? Well, the first thing to look at is, what does the mentee need? Some of them just need help getting started and finding work, getting set up, that sort of thing. And that is what I'll do as a mentor, is I will help guide a person, giving them the resources to get set up and get started, and then finding them work, and then finding them the next bit of work, and growing them that way of like, here, feed you work. Another thing is, sometimes a person wants deeper insight into how things work, and sometimes I can do one-on-ones, explaining things, or might do a video or presentation about it. Like this presentation about browsing contexts and dock shells, if I ever have a mentee who's like, I want to know more about dock shells or browsing contexts, I'd show them this episode and say like, okay, skip the questions at the end, skip all the preamble at the beginning, but go to the part where I start drawing, and that might be useful for them. And mentoring is not just about technical stuff. Sometimes it's about career stuff. What does the person want out of their career? And what is the shortest line we can draw to get them there? Shortest, most practical line. And what's a plan to... And then let's put together a plan to get them on that line and figure out how to measure how they're progressing. And that's kind of a managey thing as well. But for some people, I'm not managing them. I'm just mentoring them. But like, yeah, what do you want? Do you want to get a promotion? Okay, well, what is the job description or of the person, of someone at the next level? Let's look at that. Figure out how we can put together a case for you to say, like, I am performing those duties. I deserve the promotion. And if you don't fit the model, what can we do to make it so that you fit that model? Like, what extra things can you do, or what initiatives can you take upon yourself to grow yourself into someone that should be assigned the promotion. So hopefully that answers my question on what I tend to do whenever I mentor someone. It's not a cut and dried like cookie cutter process. It's very tailored to the person, you know, like what do they need? What do they want? What do they want out of it? If I had an extra hour of time each day, what would I spend it on? Reading. I'd read more. Despite the fact that I spend most of my day reading, code, documentation, stuff in an editor, I actually feel like I haven't been reading as much as I used to and as much as I want to. And so I'd spend it on reading, or if I had a block of 3 hours every day to do whatever I wanted that didn't include maintenance things. Maintenance. How do you spell maintenance? Oh man, maintenance. Maintenance. How do you spell maintenance? Maintenance. Maintenance. What? Maintenance. Doesn't include, that didn't include maintenance things like doing laundry or taking care of the yard or cooking or cleaning. So let's suppose I'm not taking the spare time to do those things. It's like things of whatever I want. I would probably get better at drawing and painting using my new drawing tool, and maybe cartooning, and maybe I'd work on designing a point and click adventure game, which I love point and click adventure games. Have you ever considered switching to Linux? Have you ever daily driven some Linux distro? Yes, for a long time I ran Ubuntu. I started with what did I start with? What was it called? Knoppix was my first introduction to Linux. Was you booted it off of a CD, and then I used Fedora for a little bit, and then I used Ubuntu almost exclusively in school. And I only switched to Mac OS when I started working for Mozilla. And actually, I was using Ubuntu for the most part whenever I started contracting at Mozilla and I was working on Thunderbird. But I switched to Mac OS eventually because I need to be able to virtualize all of the other... Running on Mac OS means I can virtualize Windows and Linux. But if I have Ubuntu, I can virtualize Windows. I can't virtualize Mac OS. You can't virtualize Mac OS legally. And I didn't want to have multiple machines. So Mac OS was sort of the compromise where I've got a Linuxy-like machine. It's like POSIX compliant. I have a shell. I can like do stuff like that. And I can virtualize all the other desktop types that I need. So I switched off of Ubuntu to Mac OS. And it was relatively painless. So hopefully that answers your question. I'm seeing in the chat that people are like, yes, more deep dives. If you have questions on, or if you have ideas on what I should do deep dives on, let me know in the rate this episode form. Give me ideas, give me more questions, give me, what sorts of things should I do deep dive talks on? I'd happily do it if I know what I'm talking about. And if I don't know, I can go find out maybe. Or I can make an educated guess. Before I sign off, because we're pretty much at time, I want to mention there's no episode next week. I have unavoidable meetings. I cannot avoid them, I'm afraid. So there will be no episode next week, but I will be back the week after in October, mid-October, for episode 265. And with that, I think I'm going to close it out. Thanks so much for watching episode 264 of The Joy of Coding. I actually want to do a quick special shout out before I close out. Let me actually put this in the agenda. Where can I find this person's name? Special shout out to someone in the someone in my YouTube video channel was commenting. They said that they'd been watching and that they'd broken their arm recently and that they were watching the series and it was helping them. I need to find their name. Hold on a second. Let me do this in a separate window. And I want to just give them a quick shout out. So what is their name? Let me quickly go to all the comments on my channels. It's from a person named their screen name is Shitty Skydiver. To Shitty Skydiver on YouTube. Apparently these videos are helping keep them company. They're hoping to they're hoping to heal up soon. I hope all the best. Their dominant arm is injured and they're having to type with one hand. So I wish you all the best. I hope you get better soon. I hope your arm gets back in shape and then you can start typing with both hands again, because I know typing with one hand is very annoying. And I'm glad you're a Firefox user. He says Firefox is a favorite browser, so thank you very much. I'm glad you're working on it. Or I'm glad you're enjoying the stream, and I'm glad you're using it. And if you want to contribute to Firefox itself, I want to mention, and this goes for all of you, there are mentored bugs available. If you go to codetribute.mozilla.org, you too can contribute to Firefox. You just find, and it doesn't have to be Firefox, any sort of Mozilla project. This is the list of projects for which there can be mentored bugs. So if you want to work on the JavaScript engine, here's the list of mentored bugs on the JavaScript engine. And get a Bugzilla account, go ahead and comment, and you can start hacking away. And with that, I'm going to close out. Thanks again for watching episode 264 of The Joy of Coding. It's been so good having you here, and I will see you in a couple of weeks. Take care. Bye-bye. Oh, hang on. I got to open up Whack the Morning DJ again for the closer. Bye.
The joy of coding.
See ya.